Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at modular programming with DLLs. In our last video, we successfully extracted a function from our main executable and placed it within a DLL. And we amended our source code so that we no longer needed to use an include file for the source code which did the sorting, and we placed this declare function at the beginning of our code to reference the new function within the DLL. Now, as a proof of concept, this is fine. However, if we have two separate developers or two separate teams developing the software, the team developing the DLL would need to provide this declaration to the other team in order for them to actually use it, to give them details of the name of the DLL, the name of the function within the DLL, and the number and type of the parameters. Now, you may well be creating DLLs to either give or sell to third parties. In that case, documentation is essential. However, how would they know the name of your function within the DLL? So one easy way to handle this is to extract this declare function and put it into a documented include file. And then the users using your DLL can then just include that include file, and should they need to find out the name of the function or any of the parameter details, they can just look at the include file itself. So what we're going to do today is to create an include file which will encompass the declaration of this function and its documentation. So we will comment out this section of code here, and we will create a brand new library to contain our include file. And we will save this new include file and call it pb sort include. So at the top of our new include file, we want to put some documentation in. Now in our DLL, there is only one single function which is exported, but there may well be multiple functions in any libraries which you develop. Therefore, ideally you want to document each of them at the top of your include file. This should at the very least give information on what the purpose of the library is and what the purpose of each function is. And then for each of the parameters, for each of the functions, you want to document what kind of parameter it is and how it behaves. This information will be absolutely vital to the developer who's going to be using your DLL, because in many cases the developer will not have access to the source code for the DLL. Therefore, this is the only way they will know what functions are exported and what the parameters of those functions are actually going to be. In many cases, documentation is something that many developers are not keen on doing. However, documentation is very useful, not only for passing to third parties, but also when you come back many months or sometimes years later to look at the code you yourself have written. Documentation can be very useful indeed. So now that we put some documentation in our include file, we need to put the declare function in. And there we have the declare sitting inside our include file. So we just need to add this include file to our main application. And having added this include file, we can now run our application. And it runs quite happily. Another question that may have actually crossed your mind is, how does the application know where exactly to get the DLL from? If we have a look at our new include file, we'll see that we have specified in the declare the name of the function we're actually going to be calling inside this DLL. But there is no implicit path in this command to say where the DLL is to be found. What Windows actually does when your application tries to reference one of these DLLs is it first looks in the same directory or folder that your application actually sits in. If the DLL is found in there, then Windows will actually connect the DLL to your application. If the DLL is not found within that directory, Windows will then look inside the Windows system directory. If it's not found in there, Windows will start to work through your environment path, look inside each of the folders within that path to see if the DLL exists. And after all of that, if it still cannot find the DLL, you will get an error message. For example, in our code here, if we just rename this DLL and try to run our application now, it would bring a message up to say that the code execution cannot proceed because PB_sort DLL cannot be found. However, what if you want to place your DLL in some other folder? Say for example we have a subfolder in here called DLLs. And we want to move our DLL into this folder. How do we actually change the code in our include file to reference this? Well, quite simply, we can put the name of the folder in here, and this relative path will allow our application to run and find the DLL. And the application runs quite happily. So we can do all of this without making any change to the DLL itself. We just have to change the path to it. So this approach gives you a little more flexibility on where the DLLs actually sit in your application. You may want to have all the DLLs in some common library and your executables in the folder above it. So using this approach of documenting your DLL in a separate include file with details of the parameters that this function actually takes, and if there are any other functions, then any users who are going to access your DLLs will be able to do all of this without any additional documentation. Hopefully you will find this approach useful in your development of DLLs. But that's it for today. Thank you for watching.